Have you ever looked up at the night sky and wondered how fragile our solar system really is? We often think of the planets as permanent, unchanging worlds that will always follow the same paths. But what if, without warning, just one planet suddenly vanished? No explosión, no collision. One moment it exists and the next it is simply gone. It sounds like science fiction, but asking this question reveals how beautifully connected our cosmic neighborhood truly is. Every planet, from tiny Mercury to giant Jupiter, plays a role in maintaining the balance of the solar system. Their gravity constantly interacts, creating an invisible dance that has continued for billions of years. Imagine waking up tomorrow to discover that one of these worlds has disappeared. At first, nothing might seem different on Earth. The sun would still rise, the moon would still shine, and life would continue. But deep in space, the consequences would already be unfolding. The missing planet would leave behind an empty place in the gravitational web, and every other planet would slowly begin responding to that change. If Mercury vanished, the effects would be relatively small because it is the least massive planet. Yet scientists believe even its absence would slightly alter the orbits of nearby planets over millions of years. Tiny changes, repeated endlessly, can eventually become significant. If Venus disappeared, Earth would lose one of its closest planetary neighbors. Venus and Earth share many similarities in size, and although its gravity has only a subtle influence on us, removing it would slightly change Earth's orbital behavior over incredibly long periods. Now, imagine Mars disappearing. Mars serves as more than just a fascinating destination for future explorers. Its gravitational pull helps shape the asteroid belt. Without Mars, some asteroids could slowly drift into new paths, increasing the chances that a few of them might eventually cross Earth's orbit. The solar system is a delicate balance. Every planet plays a unique role in maintaining the solar system's stability. Even though planets are separated by millions or billions of kilometers, their gravitational forces constantly interact, keeping the entire system in balance. When we look at the solar system, it may seem like each planet is simply traveling around the sun on its own. In reality, every planet is part of a delicate gravitational network that has remained stable for billions of years. Each world, regardless of its size or distance from the sun, contributes to this remarkable balance. Gravity acts like an invisible thread, connecting every planet and influencing the motion of every other object in space. This constant interaction keeps planetary orbits predictable and prevents the solar system from becoming chaotic. Even the smallest changes in one planet's orbit can slowly affect the paths of others over incredibly long periods. Scientists use powerful computer simulations to study these interactions, revealing that the solar system is far more interconnected than it appears. This balance was not created overnight. It developed over billions of years as planets formed, migrated, and settled into stable orbits. Because of this long history, even a seemingly minor disturbance could create ripple effects that spread throughout the entire system. Although these changes would happen gradually rather than instantly, they demonstrate how sensitive our cosmic neighborhood truly is. The solar system is not just a collection of isolated worlds orbiting the sun. It is a carefully balanced system where every planet plays an important role, reminding us that the universe is built on harmony, connection, and the steady influence of gravity. The loss of each planet would have different consequences. If Mercury, Venus, Mars, Jupiter, Saturn, Uranus, or Neptune suddenly vanished, each disappearance would create unique effects, from slight orbital changes to increased asteroid threats and major gravitational disruptions. If one planet suddenly vanished from the solar system, the consequences would depend entirely on which planet disappeared. Every planet has a different mass, location, and gravitational influence, meaning each one contributes in its own unique way to the stability of our cosmic neighborhood. If Mercury disappeared, the overall effects would be relatively small because it is the smallest planet, though nearby planetary orbits would slowly adjust over millions of years. If Venus vanished, Earth's closest planetary companion would be gone, causing subtle long-term changes in Earth's orbit. The disappearance of Mars could gradually disturb the asteroid belt, allowing some asteroids to drift into new paths that might eventually come closer to Earth. The most dramatic changes would occur if Jupiter vanished. As the largest planet in the solar system, Jupiter's immense gravity helps control countless asteroids and comets. Without it, many of these objects could wander toward the inner solar system, increasing the chance of future impacts on Earth over geological timescales. If Saturn, Uranus, or Neptune disappeared, the outer solar system would slowly lose its current balance, causing distant planets and icy objects to shift into different orbits. These changes would not happen overnight, but they demonstrate that every planet serves a unique purpose. Together, they create a stable system where each world quietly contributes to the long-term harmony of the solar system. Jupiter is the solar system's greatest protector. Jupiter's enormous gravity helps deflect or capture many comets and asteroids. Without it, the inner solar system, including Earth, could face a much greater risk of devastating impacts over millions of years. Among all the planets in our solar system, Jupiter stands out as the true giant. It contains more than twice the mass of all the other planets combined, giving it an enormous gravitational influence that extends across millions of kilometers. Because of this incredible size, Jupiter acts like a cosmic guardian, helping shape the movement of countless asteroids, comets, and other small objects traveling through space. Many scientists believe that Jupiter has played an important role in reducing the number of dangerous objects that could threaten the inner solar system. Its powerful gravity can capture some comets, redirect others into safer paths, or even fling them completely out of the solar system. Without Jupiter, this natural protection would be greatly reduced. Over millions of years, more asteroids and icy bodies could drift toward the inner planets, increasing the chances of impacts on worlds like Earth. Jupiter also helps maintain the stability of neighboring planets through its gravitational pull, contributing to the overall balance of planetary orbits. Although it is impossible to know every consequence if Jupiter suddenly disappeared, computer simulations suggest that the solar system would gradually become less stable over vast periods of time. Jupiter reminds us that the largest planet is much more than a beautiful gas giant. It is one of the key architects of the solar system's long-term structure and stability. Small changes can create massive long-term effects. A single missing planet would not cause immediate disaster, but over millions of years, tiny gravitational changes would accumulate, altering planetary orbits and reshaping the solar system's future. One of the most fascinating truths about the universe is that the biggest changes often begin with the smallest disturbances. If a single planet were to disappear from the solar system, there would likely be no immediate catastrophe visible from Earth. The sun would continue shining, the moon would still orbit our planet, and daily life would seem completely normal. However, beneath this calm appearance, gravity would begin quietly reshaping the solar system. Every planet constantly pulls on every other planet, creating a delicate balance that has existed for billions of years. Removing one planet would alter this balance, causing the remaining planets to make tiny adjustments to their orbits. At first, these changes would be almost impossible to detect. Yet over millions of years, even the smallest shifts could accumulate, producing significant differences in planetary positions and orbital paths. Asteroids and comets could slowly be redirected, increasing or decreasing the chances of close encounters with planets. Some worlds might drift slightly closer to the sun, while others could move farther away. Scientists use advanced computer models to study these long-term effects because they unfold over timescales far beyond a human lifetime. This demonstrates an important principle of astronomy. The universe is incredibly stable, but that stability depends on countless small forces working together. Even a tiny change, given enough time, can reshape an entire planetary system. Everything in the universe is connected. The solar system demonstrates that every object has a purpose. The invisible force of gravity links every planet together, showing that even one missing world could affect the entire cosmic system in ways that take millions of years to unfold. One of the most fascinating truths about the universe is that the biggest changes often begin with the smallest disturbances. If a single planet were to disappear from the solar system, there would likely be no immediate catastrophe visible from Earth. The sun would continue shining, the moon would still orbit our planet, and daily life would seem completely normal. However, beneath this calm appearance, gravity would begin quietly reshaping the solar system. Every planet constantly pulls on every other planet, creating a delicate balance that has existed for billions of years. Removing one planet would alter this balance, causing the remaining planets to make tiny adjustments to their orbits. At first, these changes would be almost impossible to detect. Yet over millions of years, even the smallest shifts could accumulate, producing significant differences in planetary positions and orbital paths. Asteroids and comets could slowly be redirected, increasing or decreasing the chances of close encounters with planets. Some worlds might drift slightly closer to the sun, while others could move farther away. Scientists use advanced computer models to study these long-term effects because they unfold over timescales far beyond a human lifetime. This demonstrates an important principle of astronomy. The universe is incredibly stable, but that stability depends on countless small forces working together. Even a tiny change, given enough time, can reshape an entire planetary system.